Hello. So welcome back to the video series on operating system, and we have seen the introduction to the concept of the process and the various states of the process, which are new state, ready state, running state, waiting state and terminated states. And we looked on into the PCB, process control block, which stores the information and the entire details and the information about the process, and how the CPU switches from one process to other process was discussed in the previous video. And now we are going to look on into the operations on process. Basically, a process can be created and terminated. So these are the two basic operations, and let's now see how these operations are carried out on every process and what are the system calls used for creation. Yes, so to start with the process creation, when a process creates any sub-process, the process which is creating is called as parent process, and the sub-process created is called as the child process. So always it means that parent process creates the child processes. So in order to create this child process, we have system called as fork. So generally, when the process identified and managed via a process identifier, that means that because when there are several processes, every process must have a unique identifier to identify. Let me tell us P1, P2, P3. But internally, the OS assigns with the ID for every process. So that is called as PID, process ID. And this process ID differs for a parent process and also for a child process. And now, how the resource sharing options are carried out. The parent and children will all share the common resources which are allocated to the parent process. Second, the child share the subset of parent process. Sometimes the children or the child process may not require all the resources of the parent, so it may use the subset of the parent process or resources. And sometimes the parent process and child process may not require any resources. So the resource sharing may be fully, partially or none. And the execution options means that when parent and children are executing concurrently, they can reside there, or then parent process has to wait until all the children completes and terminates. It means that when the parent and child process are not related on a common task, they can execute parallelly or concurrently. In turn, if the parent is fully dependent on the child operations, then he has to wait for the children to terminate. And this is a quite example of a list of processes where the root process is given. It creates 3 sub-processes. In turn, again, they are creating more number of sub-processes. If you can look there, we have every process is created with one process ID. There's a unique process ID assigned with every processes, and the name of the process is also there, whichever the process is executing. So this is called as the assign of PID. Now, to continue with this process creation, whenever the parent and child are not executing parallelly, we have to look on how they are going to execute. So as usual, when the fourth system call is issued, it creates a new process. That means parent process is there, child process is there. Immediately the parent process, when it issues the fork call, it enters into the wait state. Means that he has to wait for the child process till execution completes. So after the fork call, now the child enters into the execute state or the execute system call, and it executes all its work. After it completes, it issues the exit system call, means that it has completed and terminated. This information is conveyed to the parent process where he is waiting, and now he resumes with its own operation. So this is how the child and the parent are going to be executed. And the next operation carried out on the process is called as the process termination. So in this process termination, it means that when the process successfully completed its execution in the CPU, it has to abort or terminate its execution. So that is called as always process termination. We have lot of scenarios where the process can be terminated in various ways. If suppose a process has its child process, and both processes are not executing parallelly, then the parent process must wait for the child process to complete its execution. If there are n number of children, then all the n children has to complete its execution, and then only the parent process has to terminate. In all the cases, when we want to terminate a process, we have to execute the system called exit off. So that's the only system call where it terminates the process. In the next scenario, if a particular child process is not giving back the resources occupied and it is making more time to execute, the parent process may terminate the execution of the child process. So that can be issued using the abort system call. So forcibly we are aborting the working of a child process by the parent. In those cases, the scenarios may be the child has exceeded the allocated resources, or else the task assigned to the child is no longer required, or maybe the parent is exiting and its operating system does not allow the child to continue if its parent terminates. So these are the various scenarios where we are going to use the exit system call or the abort system call to terminate the parent process or the child process. Thank you.